So alcohol is a really interesting molecule because it has a kind of a nonpolar kind of carbon end, but it also has this hydroxyl group. So it's a small molecule too, so it can actually a charged hydroxyl group, so it can get through membranes actually relatively easily, but it can also sort of stick into membranes, stick the carbon end into the lipid portion of the phospholipid bilayer and have its little hydroxyl group oriented either extracellularly or intracellularly, and so it can disrupt membranes. And the more you consume, for example, the more disruptive it actually gets. And some of those proteins that sit in the membrane, that are dependent on all the electrical forces, and the composition, the specific composition of the membrane may change their form, their structure in that altered environment because of the presence of alcohol, and that could generate a whole bunch of what we call nonspecific effects on the functioning of these various protein machines. And that's kind of hard to quantify specifically in terms of what alcohol is doing, but it's definitely having these nonspecific effects and having an impact. However, alcohol also, it turns out, interacts specifically on particular receptor targets. And at normal levels of consumption, sort of moderate levels of consumption, and there's information up here on like what an actual drink is. They recommend, the National Institute on Alcohol Abuse and Alcoholism, the NIAAA, at the federal government recommends a certain, level of moderate, what they define moderate drinking. And they talk about it in terms of the number of drinks. But if you, have a night howler, from, Bear Lake Brewing in Portland, this is probably more alcohol than and it's larger than what they would define as a typical drink, by NIAAA standards. That would be like 1 12-ounce beer at 5% alcohol. This in like a Fort George Gavatica or somewhere that could be significantly higher, and this is 16 ounces, right? So the specific effects of alcohol though include agonist activity at the GABA A receptor. So alcohol will interact with the GABA A receptor and, increase chloride flow, hyperpolarizing chloride flow into the cell, and act to inhibit neurons. That's one of its actions, drug actions, at moderate levels. And then it can also act as an antagonist at the glutamate NMDA receptor. We'll talk a little bit about that. That has significant potential impacts over learning and memory. At higher levels, at very high levels of alcohol consumption, alcohol starts to have action at serotonin receptors and also acetylcholine or cholinergic receptors. So it's a messy drug. It can have lots of nonspecific effects and also like a lot of these specific effects, and those could be to some extent sort of dose dependent on how much alcohol you're actually consuming.